Hi and welcome to the University of New South Wales and in particular the School of Mathematics and Statistics. My name is Thomas Britz and I'll be looking at problem 75 for the course MATH3411. The aim of this problem is to factorise a number, in this case n, which is 83,411, or I suppose you see 83411, a little silly maybe, but there you go. We want to factorise it using a particular technique which is Fermat factorisation. Now, this is sort of similar just to trial and error, where we just try to see whether small numbers factorise that, and we just keep trying bigger and bigger numbers, except it's a bit more intelligent. So what we do in particular is we try to find some numbers s and t, so that n is equal to t squared minus s squared. If we can find such numbers, then we can of course write this as the product of s plus t times s minus, times t minus s, and there we've factorised our number n. So that's what we'd hope to be able to do using this scheme. Now it's a lot more efficient than just trying the numbers like 2, 3, 5, etc. and seeing whether they divide this number. And let's see how it works. So first of all, we start off roughly around about the square root of this number. So we calculate the square root of n, and we round up, and that gives you 289. So that's the first number that we'll look at in this algorithm here. Now we want to calculate s squared, which is going to be equal to t squared minus n. These numbers here, these s squared numbers, they're not necessarily square integer numbers, so they're of course square real numbers, but we want to find, we want to hope to find at least one of these numbers that we'll generate here to be a square integer number, and then we can factorise, as I said before. So first of all, we have to calculate this very first term. So t squared, this number here, minus n, and that gives you 110. So there's a tiny bit of calculation right here in the beginning. We also want to calculate 2t plus 1, so that's 579. And at this step and every other step, we're going to ask, is this number a square? So in other words, s squared is 110. If we take the square root of that, is that an integer? And the answer is no. Well, let's draw a red cross like that. So as long as that's the case, we continue. So the next value of t is 290. And here, to get the next number, this is just 2t plus 1. Here we've added 1 here, so we're adding 2 here. So this is 581. Now to get this number here, we just take that number there and add it onto here. So we get 689. And the reason for that we just add this number here, is if we see if we have s squared being equal to t squared minus n, then if we see what happens if we have t plus 1 squared minus n, that's equal to t squared minus n plus 2t plus 1. So that's exactly that term there that we have there, and this was our original s squared term. So we take this number and this number, add them together, and you get the next number here. So it's all very efficient, these calculations. So let's continue. We first have to check whether our new s squared value is actually an integer square, and Well, you can sort of, since the numbers aren't much bigger than that, we can recognize that this is not a square number. Of course, you could use a calculator or something, or other methods to check whether this was square, but so far we can recognize this to not be square just straight off. So let's continue. So we have 291, 583, and then we get 1270, which again is not a square, so we continue. Then we have 292 and 585, and then we get 1853. That is still not a square. Oh, I hope we get a square soon. Let's see. And we get 293, 587, and 2438. Ah, that is still not a square. That's very close to, well, I suppose it's not very close to being a square, but it's not far from being 50 squared, but it's not quite. So 294, 589, and that number there is then 3025. Ah, okay, that's a square number. We recognize that as 65 squared. Oh, sorry, 55 squared. So we suddenly, or finally, we've found one of these numbers which is an integer square, and then we're done. Now we just have to write up what the factorization is equal to. So here t was this value here. So t is equal to 294, and s was equal to 55. So if we call a the sum of these two, then we have that that's 349. And if we say that b is the difference between these two, then we get 239. And then by what we said before, we have that n is equal to a times b, or in other words, equal to 349 times 239, and we have broken n up into two factors, and if you look at those factors, well, I suppose you'd have to look a little harder than what I can do right now, but both of those are prime if I'm not mistaken, so we actually have a prime factorization right there, and we are done. So, thank you very much.